Okay, so we are going to talk about how to solve inequalities. Inequalities are what we did yesterday. What's the difference between an inequality and an equation?
An inequality is you don't solve that problem, but an inequality you do.
Well, we actually today are going to learn that we can solve both of them. But what's the main difference between an equation? Casey? Okay, so the numbers are not equal, so an inequality is not equal, so then what does an equation have that an inequality does not have? The equal sign. Okay, that's your biggest difference. An inequality starts with, or we're using the signs greater than, less than, greater than or equal to, less than or equal to. So where we have an equation with just an equal sign, the other we have 4 signs we'll be using. The first type of problem that we're going to look at is where you're determining if a solution works for an inequality. So if we have the inequality y plus 5 is less than 11, and they tell us that y is equal to 7. So this would be the information that the problem gives you, and you have to decide if that can be true. So thinking back to our commercial, what are we going to do when we are told what our variable is equal to? We plug it in. You're right. Okay. So I'm going to make that y become a 7. So 7 plus 5 less than 11. What's 7 plus 5?
12.
Is 12 less than 11? No. So can this be a solution?
No.
So your answer would be no. So you're determining if the solution will work for that inequality. You'll have situations where you're given one option and you have to tell yes or no. If this were a greater than sign and you had 12 is greater than 11, then you would say yes, it could be a solution. And then you'll also have times, I'm going to use the same one, where you're given options. And we have the numbers 5, 6, and 7. These are supposed to be brackets. I'm not great at drawing brackets. So what you're going to do is you're going to start with your first option. These are the choices we have. So I'm going to plug 5 in for y. So this becomes 5 plus 5 less than 11. What's 5 plus 5?
10.
Is 10 less than 11?
Yes.
Okay? So this works. All right, I'm going to go to my next one. 6 plus 5 less than 11. What's 6 plus 5?
11.
Is 11 less than 11?
No.
No. Now, do I have to test 7?
No.
Why not?
Because you already did that.
How did I do that?
You already found out.
You already found
And you know if it goes higher,
You already
it's
did
going to go over.
Exactly. Well, you could have more than one. So don't think about you've already found the answer, because you could have all 3 be solutions. But what you guys were saying about, if I know that 11 is equal to it, anything higher than 6 cannot be a solution because it's going to be greater than 11. So once you figure out, really all we had to do was test 5. Because 10 is the only thing that could be less than 11. If I go over 5, then it's going to be greater than 5. Greater than 11. Mm-hmm.
So how do you know when it says less than and greater than? Will it say on the top?
Right there. Right there, less than. It'll tell you in your sign. Okay? So that's what you're doing when you're determining if the solution or if the number could be a solution to your inequality. You'll either have one and you'll tell me yes or no, or you'll have multiple answer options and you'll have to decide which ones work. And as I said a minute ago, you could have none of them be a solution, or you could have all of them or some of them. Okay? All right. Any questions about this so far? No. You're just plugging it in and seeing if it works. Okay? Let's talk about another thing we can do with inequalities. And this is combining what we already know about equations. And we know how to solve an equation. So now we're going to apply that to an inequality. Okay? If I have this inequality, and you're used to seeing this except for here, we would have an equal sign. If there were an equal sign here, how would I solve this?
Y would be a 3.
I would subtract 6 from both sides, right? Guess what I'm going to do now? The exact same thing. Just because your sign changes in the middle, you're still going to solve it the same way. So because this is an addition inequality, I solve it using subtraction. You got it. We're using the inverse operation. So I want to get rid of the 6 because it's with my variable. So minus 6 to both sides. What happens here? It cancels out. That leaves y by itself. I bring my sign down, less than or equal to 9 minus 6 is 3. So this tells me all of my options that would work to make this true would be less than or equal to 3. Mm-hmm.
So you would only do that for greater than or equal to?
You're going to do them for all of them. Yeah, you're going to do the same exact thing if your sign is less than, greater than, less than or equal to, or greater than or equal to. Yeah. It'll tell you solve the inequality, and you're looking for the value of y, or the value of the variable. Okay, let's try this, and let's graph this one. This is what we did yesterday. Okay, so I'm going to draw my number line, do a couple of numbers before and a couple after. Now, thinking about what we talked about yesterday, am I going to have an open or closed circle on 3?
Closed.
Closed. Why is it closed?
Because it has the equal to sign.
You are right, because it's also equal to. It's less than or equal to. So closed circle on 3, and which direction do I shade in?
Left side.
Left, because it's less than, and that's also the direction that the arrow is pointing. So this tells me all of my answer choices for this inequality would have to fall on this side of my number line. And again, you're doing the same thing we did when we solved equations. Just because we don't have an equal sign, you don't change any of your steps. Okay, let's try another. We got C divided by 3 is less than 10. So what type of problem is this? Division. And I solve it using multiplication. Okay? What happens to my 3's?
They disappear.
They do disappear. They cancel each other out. So C is less than 10 times 3?
30.
Okay. So it tells me C has got to be less than 30 for this to work. So I can graph it. Okay, oops, slide over just a little bit. All right, open or closed circle on 30? Open. There's no equal to, so it does not include the number 30. And everything to the left, because it's less than. Why would it not include 30?
Because it's less than 30.
It is. But what happens if I had 30 divided by 3? What would I get as my answer?
10.
Is 10 less than 10?
No.
No. So this one does not include 30. It'd be anything less than 30. Okay. Any questions so far? I know we're just getting started. Yes.
So your answer will be
Right here.
whatever the number is subtracted from the far right number.
Well, whatever operation you're having to undo. So like this one was division, so whatever I multiplied by was what I got. It's the exact same thing you did on your equations, and everyone proved to me yesterday you knew how to solve equations, right? Because we completed our checkpoint. So you're doing the same thing. Don't let the sign throw you off. Okay? The sign just means we're now not talking about equal to. It can be greater or less than as well.
So that would be yes.
Well, you're not always subtracting. No, you don't have a yes or no answer to this. Your answer is C is less than 30. The others, it's where it's given you the value, and you have to decide could it be true or not. So you're doing two types of problems here. One you're actually solving. The other, they give you a solution, and you tell me if it works or not. Okay? All right, Lauren.
So with the second problem you did,
Hmm?
3, like the C over 3, and
Yep.
then the other parentheses, how do you do that?
So this is division. Remember, a fraction shows division.
Yes, ma'am.
And I'm going to undo division by multiplying. So my parentheses just show multiplication. And so what's happening right here, if we look at this problem, okay, this really is the same as 3 over 1 times C over 3. Well, remember, with multiplication of fractions, I multiply straight across. So 3C over 3, and what's 3 over 3 equal to? 1, and 1 times C is C. So that's how they actually cancel themselves out. Okay? Yes?
You have to show the graph.
Yes. You won't do it on the top problems, but on the bottom here, yes. When you solve it, you will need to graph it. Yes. All right, any other questions? Okay, we're going to get started together here in just a second. The what now? Not on this one. No.